Hello, everybody. Welcome back to this week's LeetCode Contest Corner. Blue Thunder here. It is week 358. This week was I I'm pretty proud of this week. I think I did pretty good. A little bit tricky, but I was able to remember what I learned a bit. And I got two done. Let's go. I actually did something kind of interesting with both, so we'll get into that. Of course, as always, congratulations to John Cram for winning this week's contest. Good job. Congratulations. So let's get right into it. As always, I will go through each problem. I'll read the description and then I'll explain it so hopefully everyone can understand. And then I'll go through my code to describe how I completed the problem. So we'll start with max pair sum in an array. You are given a zero-indexed integer array nums. You have to find the maximum sum of a pair of numbers from nums such that the maximum digit in both numbers are equal. Okay, so right, so yeah, but yeah, okay, you're given an array, um, and basically you want to find two numbers in the array that added together are bigger than any other two numbers you could have picked. Right? So that's pretty simple. So then it's like, oh, why don't I just pick the two biggest numbers? Well, that's because the second condition here says the maximum digit in both numbers need to be equal. So in this case, um, yeah, okay. So in this case, the only two number there's only 71 and 17 and 24 and 42. Those are the only ones with them. So like see here 71 and 17, the 7 is the max digit, the biggest digit in both the numbers, and so those two could be added. And then in 24, oh, also the ones, well, okay, sorry. And then 24 and 42, 4 is the max number in both the max digit in both the numbers, so those could have also been pairs. But obviously 71 plus 17 are bigger, so the answer is 88. So that's what you're looking for. I don't know, see, they pick all the numbers here, like, yeah, the only numbers that work together are like, um, I think it's anagrams. I think that's what it's called. That was like the first contest we did, and I can't remember the word for it. But anyways, um, yeah, they're like backwards. They don't need to be. It could be like two numbers that could work would be like 51 and 25 because they both have the biggest number are in those the biggest digit in those two numbers are 5. But I don't know. There's just a weird example. But and then also here it says return this maximum sum or -1 if no such pair exists. Dude, I didn't even read that. Like whenever I see like stuff that's like lighter, I guess my brain, because of school, it just tunes that out. It doesn't even notice it. So yeah, so here there none of these numbers have a digit that even they don't share any digits. So the output would be -1. And then also, I guess two numbers that wouldn't work would be like um uh would be like 92 and 80 and 82, right? 92 and 82. They share a 2, but it doesn't work because the 2 in both of those numbers doesn't work. So they wouldn't be a max pair. So that's important um, to keep in mind. So let us get into my code. Um, where are we? Yeah, so max sum right here. So we're going to want to return an int. We have nums array as a parameter. So we get started with max equals -1. I create this variable. if we can't find a max out of all the numbers in the array, then this -1 will be our answer. So that's why I made sure to have this set at -1. Um, then, um, oh, is this? Yeah, that's sorry. Right. Wait, this isn't the one, is it? Because oh, sorry. There's something a little bit like this, like later on the third problem. Sorry, I got myself confused. Okay, so all right, we get into this for loop. It starts at this one starts at 0, and it'll go through all of them. But for each one, we go through this second for loop, which starts at I+1, which is means we're starting. This will go right after what I is. So this, so so we got I, like, so I'll be 0. That's an O, 0. And then J will be start at 1, then it'll go 2, 3, 4. Then we'll go to 1 for I, and then we'll go 2, 3, 4, and then 2, 3, 4, 3, and then 4 for I. So that way we check all of the pairs. So yeah, so we go through all the pairs. That's what these for loops are about. Okay, so then we have each pair that we're looking at. Then we have something I discovered. I did a little testing, and it looks like it works fine. I created another method to help me out, to make it easier. So here I have find max digit. So let's go down to that method to see what that's about. So find max digit, pretty simple. You put in a number as a parameter, and it gives you the digit that's the highest out of all the digits. Pretty simple. Um, and this one, okay, this one actually uses us. If you haven't heard of it, it uses a cool new thing called recursion. Um, I think that was the easiest way to do this, so I was like, let's do some recursion. That's always fun. Um, so if you don't know what recursion is, I'll show you, baby. We'll see how it works. Um, all right, so we start here. So we're looking for the max digit. We start here. If x is less than 10, then return x. Because if there's only one digit, the max digit can only be that. It can only be that. Um, so yeah, pretty simple. This is what I like, not just me. This is what us computer science people like to call the base case. Okay, this is an important part for later. But yeah, simple. If it's just a single digit, then it returns that digit. Okay. Now now I want to look at each digit, right? So let's start. So what I do is like, okay, I want to look at the last digit of the number. So I create a variable called simplex. This is the best name I could think of. I had a different name, and it was like the first ones place, or the ones place or something. It was confusing, and I just went with simplex. So what I do, okay, you need to keep track of the number. What's simplex? Simplex equals x divided by 10. So say x is 1, 2, 3, 4, 5. So now it's saying x divided by 10. Now this is an integer, so dividing it by obviously normally dividing it by 10 would make it 1, 2, 3, 4.5, but it integers can't have decimal places. So what Java does, I'm sure a lot of programming languages do. I don't know if any are different. Um, it just cuts it off. Simple dimple. It just makes it 1, 2, 3, 4. You don't get the 5, which is really helpful. There's no estimating or anything like that. It just cuts it off, which is really good, really helpful to know. So it cuts it off. Um, okay. Then then so it does that. Then we say, okay, simple x equals simple x times 10. So this makes the number 1, 2, 3, 4, 0. So it adds a little 0. That'll be helpful. Okay, so that's what simple x is. Then I have, so then I create a variable called last digit. Okay, so this is like what I want to put into here is the last digit of x, right? So I have x, which as you remember is 1, 2, 3, 4, 5, minus simple x, which is 1, 2, 3, 4, 0. So then when you subtract this simple x from x, you'll just be left with the 5, aka the last digit. Um, so that is that part. So then we got the last digit. Um, then, okay, this is where the recursion part comes in. All right, I don't think we'll need this. Then, okay, then yeah, okay, sorry, maybe we do. 1, 2, 3, 4, 0. Okay, then we take simple x, divide it by 10 again, because you'll see in a moment why. And we get rid of that. And then we do find max digit again. We call the method we're using again. That's what recursion is all about. You call the method within itself. Um, so this one will find the max digit. So basically, it'll find the max digit in this number, right? Um, and I call it Curmex. It's one way to think about it, but just think of that as a name for what it is. This is so yeah, so it will go through, right? It'll take so it just I guess right now, sorry. Right now you'll have to trust that it'll find the max digit out of this number, right? 'Cause we haven't really gotten to the max digit part yet, right? But um but trust me, we'll get there. Okay, so we have the max digit from the first part of the number, and then we have 5, right? So then we check, okay, is the Curmax from the front part of the number bigger than the max of the digit we got right now? If it is, we return Curmax. If it's not, then we return the last digit. So, okay, so we got, so, all right, we got 1, 2, 3, 4, 5. We come down, it's not, that is not less than 10, so we keep moving. We say, oh, hey, um, we do this stuff, we get 1, 2, 3, 4, and then we got our single digit 5. Um, then it goes down, then we call the method again. Okay, let's call the method again. So then we got 1, 2, 3, 4. Um, and then, right, and then we come down here, and then we got, it cuts it up, 1, 2, 3, and then we got 4. And then, oh, hey, we're calling the method again. All right, I'll keep try to make this quick. 1, 2, 3, and then we got 1, 2, 3, and we call the method again. And we got 1, 2, and we got 1 and 2, and then we call it again. And we got 1, and that is less than 10. So there we go. We return 1. We return 1. Okay, then we have uh the max digit. We have what? This will be 1. So 1, is it greater than 2? No, it's not. So then we return 2, and then right? And then we got 2 and 3. Is 2 greater than 3? No, it's not. So we return 3. Then we got 4 is right? No, we got, yeah, we got 3. Yeah, it's a little confusing, but yeah, we keep coming back. So this will, yeah, like I said, we'll have the max digit, and then it'll find the max digit in the end. I I kind of lost track myself, um, but yeah, basically it's easier. Like it's when you build it yourself, it's easier to understand. Um, so you want I guess you just want the trust the method, and if you trust the method to work, it, then you use it. It's easier to understand in your head when you build it yourself, is what I'm trying to say, I guess. So I hope I did an okay job of explaining it. Um, I guess, because I'm probably better with a flowchart or something, but um, I'll save in my paint for later. So, yeah, so that was find max digit. Okay, so if you don't understand all this, I hope you did. I did an okay job explaining. I hope you get the general gist. But if you don't, this method finds the max digit in a number. All right. So we're back up here. We're comparing the two numbers. Um, right? We got the two numbers, and we're going to go through all the pairs of numbers, like every pair, right? That's what these for loops are doing, remember? So we're checking every pair to see what they look like. So here we go. We got find max digit of nums I and max digit of nums j, right? And then if they're equal, well, if they're not equal, then we just ignore them, right? The two pairs won't work. It doesn't matter how big the number is. It's not going to help us, so we don't care. We'll just go through the next for loop stuff. But if they are equal, then that means, hey, they could be the biggest number. So then we have I make this uh, variable cur just to hold on to what the sum equals. And then if that sum is greater than the max, then we set the max to the sum. Otherwise, if it's not, then we have a bigger max. So yeah, so I think the heart of this program is in the find max digit, is in recursion. Um, I just want to show, yeah, for this, yeah. So it's pretty simple. All I had to do was add the method at the bottom. Um, I don't know why I thought it would be hard to do this, but no, they give you. I'm sorry. I think if you want to code everything you code needs to fit in the class solution thingamajig. So as long as you can put it in there, then you're good, right? Um, that's what you wanted. So I just threw it in there and it works. Um, so yeah. So you run the code, it works. It gives you the maxed pair. Yeah, like I said, I think looking at this, I mean, this other part is just comparing and adding. Like, that's easy. The hardest part is like doing the max digits, dealing with dividing it and then multiplying it and then doing the recursion. You might, I think actually, anytime you do recursion, technically you could use um, some type of loop, right? You could. I think you could figure out for any situation you could do that. However, understanding a way to do it is really hard. Um, like you gotta like, okay, what variables do I need to keep outside the loop, and what do I need to keep inside? And it's like, oh yeah, and you probably need loops of loops, and it's really confusing. But you can do it. I think any situation you can. In some situations, it's probably less because like each time you call a method, that's like a new method in the log or whatever. So it might take up more space, but doing recursion is a lot easier way of thinking about it. And yeah, once I learned that in class, anytime afterwards, like I had to retake a class once, and when we were doing easier stuff, I think I used recursion, and I don't know if we were supposed to, um, because it was just an easier way of understanding certain problems. Um, so yeah, if you don't know recursion after this, I don't blame you. But I recommend if you want to get into coding, I feel confident that this is important. Maybe it's not. They taught us this like, oh, it's helpful a little bit for niche cases, but then when you actually get into work and stuff, you'll never use it again. That's just my luck with how it works. I don't know. But I think recursion's fun. Anyways, so that was max pair sum in array. That was number one. Number two is what we got here. I know, okay, so I know I said I only got two. I did try and fail at the third one, kind of failed. So I kind of I'll go over it basically is what I'm saying. So we got that to look forward to as well. So we got this one. Double a number represented as a linked list. You are given the head of a non-empty linked list representing a non-negative integer without leading zeros. Return the head of the linked list after doubling it. What does that mean? Okay, so understanding the problem is actually pretty easy. Um, and this might look confusing, but it's easy to understand what the problem is. So you got this linked list. If you don't know what that is, I'll get to that in a minute, I think. Um, I'll do a little lesson in what a linked list is because I like explaining stuff. It's fun. But anyways, but what is sorry. So what it's saying is, okay, this is a number. This is a number, 189 basically. This is what it's saying. It wants you to double it, 189. You go double 189, you get 378. Put that in your calculator and check. That's what you get. Same thing for this one. You get 999, double it, get 1998. Um, so that's all you're doing. You're taking the linked list and then doubling it into a new linked list that is the doubled version, right? Um, I think you're noticing here, oh, it might be tricky because they're going from a 3 linked list to a 4 one. That might be a little tricky. It definitely is something. So, um, linked lists, like this is also a thing we learned in class. So this like I'm certainly not going to do it justice. It's a whole thing. Um, so yeah, so as you can see here, this was given to us, right? This wasn't here before. This is the um a class we're using. All right, I'm back. Sorry about that cut, guys. Just had to. I needed some water. Honestly, man, I'm talking a lot. All right, so like I said, we got this linked list class. Um, okay, so I'll give a quick rundown. If you know how linked lists first work, you can skip past this. Um, all right, so okay, link. What's a linked list? So sorry about every math teacher says that with me is true. I have super shaky hands, so prepare yourself. So what's a linked list? A linked list. So you got this. Let's look here. I have it here. A list node. This is a class. If you don't know what a class is, ask your teacher about it. That's a different thing. Um, but basically, so this is okay. Okay, all right. I guess it's kind of important. A class. What's a class? It's basically like a class is a type of variable basically. You got the integer class, you got the double class, the string class, the what's another class? The Boolean class. Those are all classes. All right, they're types of variables, and with those can make different variables or objects, as people call them. So using the list node class, I can make a specific list node. Okay, so it's a variable. So what? So the question is, okay, what's in each list node? What is in each one? Paint. We're looking for paint. So this is in each list node. First, you have an element. It can be any variable you want. It can be another list node element. What kind of is? But let's ignore that. You can have any variable type of variable you want. Let's say we're using integers. So this is the first. So it has two things. It has the element. Let's say it's 3, and then it also has the pointer, which is another list node, right? So this points to the next um, item in the list node, right? So he got 3. So this one would be a list, what did you just call list node is what they call it. A list node of 1, and it has a 3. And the next node is empty, is null. It's pointing at null, it's pointing at nothing. Then And this is so then if you want to add something, you could say, hey, this list node's next. Let's make it point to this new node that I made. I don't know. Let's make it a 2. Hey, I'm actually not doing too bad. And it's just pointing at this whole node, by the way. It's not pointing at the bottom. It's just pointing at the node. So then I got that. Okay, and then let's make uh, another list node. It's pointing at null until I make another one. I guess let's make it 1. Okay, so yeah, and then this is pointing at null, right? So, and then some other important things people usually call this list node. This is usually called the head, is what people call it, and then they call this one the tails, the end one. Now, getting to each one is kind of tricky. You can't just point to one and be like, I want to look at that one, because you need a variable to hold. So you have, yeah, okay, you have a variable called head. Okay, you got head, and this point, that's this one. That's what it is. So if you call head dot, what's the head's element? Oh, it's 3. So then, okay, well, I want the element of the next list node. How do I get that? I have to do head dot next dot value, right? So I go to head to the next, which is this one, and then to the value, which is 2. And then if I go to head dot next, we can get this value, head dot next value, we get 1. Then we try to do head dot next. You can try to do that, but you'll get null. So that's basically what you want. Or you can say, hey, okay, I got this head node, but I want the second node. So I want to go to head dot next. Okay, so then I got this node. So I want to put head dot next into C here. Let's call it. So then if we put this into here, we can put a copy or whatever, and so we can have that basically. Um, sorry. Okay. So um, yeah. So something also you want to make sure what when you're dealing with the list you want to deal with, and you want to make sure to also be careful when you're dealing with copies and stuff. All right, so you don't want to overwrite something important in the main list, and you don't want to try to act like you did anything important when you're just doing something with a copy. That's also important. So just keep that in mind. So let's go. Hopefully now you get a simple idea of how list nodes work. So we'll get into the thing, right? So we got this list node starting at the head. So it gives us this. It gives us the head of this list node, right? So if we do, we'll have 189. All right. So here we go. What I did. So this is important. Um, so I created, um, okay, I created a copy, right, called cur to hold on to the head. I guess I did that um, to uh, easily deal with the stuff and all that jazz. And then, okay, this is important variable count, because remember, it's really hard to get to each list node. So I needed a count to keep track of where each number was, each part of the digit was, and how long it is, and all that jazz. And then I created a list node result um, equals null. Um, so this variable is going to hold our resulting list node. The resulting is going to be the head, more specifically, is going to be the head of the list node we create, right? So this is going to hold on to it. So yeah, so this is why I created cur. This is right. So first, I want to count how big the list is. So cur.next, the right, that's pointing to um, when the next node is empty, right? So when it's equals null. So I'm saying, well, it's not equal to null, right? So this is like, hey, keeps looping until as long as there's a next node, right? And so count is a little bit deceiving because if we have exactly one node, then the count would be zero. Now I that's still I can work with that, and I did, but that is something important to keep in mind. So yeah, so this counts in a way. It counts how many nodes there are in a fashion. It count. Well, basically, actually, it's kind of helpful because it counts how many times we need to loop until we're at the tail of the doodly doo, right? So yeah. So okay, right? So this is counting it. So how do I do that? So I start. So cur.next, the head is equal to null. Okay. So then, all right. Well, it's not equal to null. So we got our node 1, 8, and 9. So right now cur is equal to the 1. Well, I'll just say equal to 1, even though it's a node, it's not equal to 1, but you know what I mean. So cur is 1 right now. So then that's and then its tail is 8, or it's not tail. It's pointing to 8. So it's not null. So we increase the count. And then I say cur equals cur.next. So basically I'm saying cur isn't 1 anymore, cur is 8. So then we go loop again. Hey, there's the tail. Oh, or the pointer is pointing to 9, so we're good. So we can say cur.next, or we can say count. We can increase the count. So now we're saying, hey, okay, cur equals cur.next. So now cur does not equal 8, equals 9. Then we start again. Hey, was a point? It's pointing to null. So then we're stopped. So then the count is 2. It takes 2 loops to get to 9. Our last boil. So that's how it counts it. All right. Then I create this new int called remainder. I don't know if that's the exact word for it, but I'll show you. Basically, now we're gonna take a number 1, 8, 9, and we're gonna do some classic basic math, right? So we're gonna add a little 2 here to double it, and then we're gonna multiply it. So the remainder, so 2 times 9 is 18, as I'm sure you all know. And so the remainder is this part right here, this 1. That's what I'm calling the remainder. Just keep that in mind. Um, and so, yeah, basically what we're doing with this part, the only tricky part is dealing with list nodes. That's the tricky part, multiplying it. Otherwise, we're just like doing basic multiplication that you've done since like second grade, right? So what's that's how you get the numbers. That's what we're doing basically. Okay. So keep that in mind as we go through this. So now we got this while loop. So while count is greater than 0. So we're going to go through all the list nodes. Um, and then once it's back at 0, that means we've looped through all of them and we're done. Um, yeah. So I guess like this is the way my brain processed it. I could have had while cur equals doesn't equal null instead of cur.next, and then I wouldn't have needed this equal sign. But see, that's just like yeah. So I was looking to get to the tail, right, the end of it. So I was like, okay, how do I get that? I don't want to go past it, right? Because once you go past it, you can't go back. Um, so yeah. All right. So yeah, so we're gonna go through the count. So then we reset the cur. We set it back to the head, back to the beginning, and then okay, what's this next part? Okay, we set it back to the beginning, but then I set it back at the end of the thing. Was that necessary? I don't know. Probably not in hindsight. I probably didn't need to do that. I don't know. This puts because yeah, this goes to the count. Oh no no no! It is important because okay, yeah, we're going to the end now. But then how do we get to the first numbers? So yeah, then so you see I equals count. So if this is our first loop through, we'll say okay, I want cur to be at So we got the head is 1, and then okay, this is our first loop. I want the cur to be 9. But then in our second loop, I want cur to be at 8. So then we'll only count will be 1, and so we'll make it to 8. And then if it's our third loop, then we just want it to be at 1. So yeah, that's what this part's. So yes, this is important to have. Okay. Okay. So then we determine what the value of. So we do math basically. Cur.value, that's the value, that's the element we're talking about. That's the in this case for our first loop it'll be it'll be 9. So we're saying, hey, that 9 equals the value times 2 plus the remainder, which at the beginning the remainder is 0, obviously. So, but that's for future loops, so that if there's a remainder, we can add it to it. Um, so like if this is, so then we do, okay, value equals 18, and then I'll tell you how I got rid of the 1 later, put into the remainder, and then we double the 8, so that's 16, but then there's 17, so right? That's the remainder part. Um, yeah, okay. So in this case, we got 9, so it's now 18 in the cur.val, but we just want it to be a single digit. So, sorry. Now we have remainder equals cur.val divided by 10, right? So that just cuts off the ending part, so we got a 1. That's the remainder. And then I made a new variable called cutter, and this is just gonna be it'll take the remainder, multiply it by 10. So then we can take cur.val minus cutter. That'll cut off any extra numbers at the beginning that we saved in remainder. Yeah, so then cur.val now it'll equal 8. Um, so yeah, now this is the next tricky part. Okay, so we got cur.val is 8, right? That it doesn't need to be in cur.val necessarily. I could have put it in a different situation, but uh, but that's what I did, right? So uh, hold on, I'm thinking what I did here. Right, right, right. Okay, so yeah, so actually, and what I did, yeah, I should have done that. Never mind. So yeah, so cur. So at this point, so we got one. So I keep writing this 188, and remember our cur is on 8 here. That's our current node we're on. So then we go down to here and we say, hey, cur.next equals result. So that's basically saying every number we've done before, I want to tag it on at the end here. Okay. At the end of our cur, right? So in this case, there's nothing. So there's nothing there. So, um, yes. So yeah. So cur dot next, and then we tag on the results at the end. It cuts off the ending that we originally had, and replaces it with result. Um, I'll don't worry. I'll show an example. And so yes. So that's yeah. So in this case, it doesn't change. There's nothing in result yet. So we just still the same 188, and then we say, hey, result. Now that equals cur. When remember, cur is 8. It's just 8. It's not any other number. So then now result is 8. And then count minus minus for the loop stuff. So then, okay, so now result is 8. So remember that. So then we go again. We got cur equals head. Then we move. And now we only move to the second one, 189. So now we're at, we got 1. What did that, what, why? 1, 8, 9, but we're at the 8. So then we go down and we double it. 8 is 16 plus the remainder, so it's 17. And then we cut it and all that jazz. So we move the 1. The remainder is 1 again. So we got 7. And then, yeah, so cur dot, yeah, all that cur is dot val is 7. Then we say, then this is the important part. Cur dot next. What's the next here? The next is 9. We're saying, hey, replace that the cur dot next with the results. What's the results right now? It's 8. So we're replacing with 8. So then it's like, oh boy, okay. So yeah, so this is what we're dealing with now. Um, and then result equals cur. So we're just replacing. So remember, cur is at 7. So then we got 7, which is pointing to 8. All right. And then I'll do this one more time, just so hopefully you get it. We're back up here. We're pointing at 1 now. We still got the 8 and 9. It's still, the 1 is pointing to 8 and 9, so we got to keep that in mind. But our cur node is 1. So then we do this again. We double it, which is 2, but then we add the remainder, so it's 3. Then we cut it. In this case, there's nothing to cut. And then, yeah, so we cut it, all that jazz, then cur dot value, and then cur dot next equals results, it is 7 and 8. 7 and 8. And then results equals cur, right? So then we got 3, 7, and 8. So that is our answer. So now, okay, so now let's say, so yeah, okay, so hold on, okay. So then we say, okay, and then we check if the remainder, in this case, there's no remainder, so it is not greater than 0. So then we return the result. In this case, it is 3, 7, 8. Now let's say we had instead of 1 at the beginning, remember it was a 1. So let's say it was 6, not 16, 6. Okay, then we doubled it, it would be 12, but then it was remainder, so it would be 13. Um, blah, blah, blah. We go down here. Then yeah, then we cut it off, right? We cut off, and then 1 is in the remainder, and then we go down here. In this case, it would be the same, it'd still be 3. And then, okay, so then we got a 1 in the remainder, remember? Okay, so then we're done with this loop. And we go down and say, oh, hey, right. So remember, so the result is 3, 7, 8. We just have 1 in the remainder. And it goes down here because the count is done. It went through all the numbers. So we go down here and we're like, oh boy, we have something in the remainder. So then I create a new list node with an element remainder. So this is creating a list node with 1, and then there's pointing to nothing. It's pointing to null. But then, and I call it new node. That's important, new node. And then I say new node.net, do new node.next equals results. So it'll point to 3, 7, and 8. And then in this case, we return the new node. So it's returns this. So there you go. That was a lot. Um, I hope you understood that. If you didn't, that sucks because like if the people who don't understand list nodes didn't understand that, then this video is not helpful for them. And then for people who do, I feel like this video doesn't help them too much unless they like watching someone explain something. I don't know. So I'm hoping you understood that. It's a little tricky, but yeah, that was the list node one. That was tricky, but I enjoyed doing it. So yeah, that was that one. So then I'll move on to this one, which I wasn't able to do. My problem with this one is, as always, it took too long. I don't know how to optimize it. I'm not good at optimizing, apparently. I don't know. So I'll still explain it because I feel like I was pretty smart. I did a little bit of optimizing, I think. So okay. Minimum absolute difference between elements with constraint. You are given a zero-index integer array nums and an integer x. Find the minimum absolute difference between two elements in the array that are at least x indices apart. In other words, find two indices I and j such that absolute value of I minus j is greater than or equal to x. And absolute value of nums I minus nums j is minimized. Return an integer denoting the minimum absolute difference between the two elements that are at least x apart. Okay, that sounds like a lot. It's not too hard to understand. Again, I promise. So let's just start. What's the main thing it's asking for? It's saying find two numbers in the array that are as close together as you can get. So in this case, it would be 4 and 4, right? Because 4 might, like, those, they're the same number. They're as close as you can get. In this one, just looking at it, it would probably be 3 and 2. They're right next to each other, so that's as close as you can get. Those two numbers are as close as you can get together. That's what it's saying with absolute difference, right? The minimum value of that, minimum value of the absolute difference. Just saying, find the two numbers that are closest together. Now, harder part um is the this part, the x. This is saying the two numbers in the array, they need to be apart by at least 2. Um, so these fours are at least 2 apart. And so this one's helpful. This helped me understand. Okay, we can select 3 and 2 because the x is 1, so they're 1 apart. So 1 just says, hey, they have to be different numbers. I don't know if x was 0. I don't know if they'd accept picking the same number, but yeah, I think X. It could have done 0. It could have picked 0. It looks like, but yeah, and I think my program probably might have still worked. I don't know. Yeah, it would have still worked. Yeah. So yeah. But basically, yeah, saying pick two numbers that are, they're apart. Yeah. So yeah, they have to be 1 apart. So in this case, we got 3. Um. So then it'd be 1 and 4. 1, 2, 3. No, 1, 2, 3. Yeah. So those are the only numbers you could have picked, 1 and 4, because there's no other numbers. So the output is 3, because it's 4 minus 1 is 3. So yeah. So how did I do it? I did it a slow way, apparently. So go down here. All right. So yeah, and it also deals with a list array. What do you call it? I guess I should say it up here. Utility list, which is obnoxious, but whatever. But this probably is like, oh, if you understood it better, you'd be able to optimize it better. So I guess that's maybe where I went wrong. I don't know. Anyways, so first we go here. We start with min equals that. Um, that's the biggest number you can have in a Java thing. If you increase it even by 1, make that 7 into an 8, it won't accept it. So that's the biggest number you can possibly have. So if you find a number, it'll be smaller than this one, basically. And if you find this number, if you've come up with this number as an answer, well, then it doesn't matter. They're the same number. So yeah, so that's holding min. So then, as always, whenever I have thing that takes too long, it's always a nested loop. Um, okay, but see, this is where I thought it was pretty creative. So this for loop, as always, it goes through all of the numbers in the list, and then the second loop, it starts at I plus x. So saying, hey, start at the closest together you can be to the index we're starting at, right? That way we don't do numbers that are too far or too close together that we can't pick them, right? So yeah, so it starts and then it goes through the rest of the array. And it doesn't matter like to the order and all that. So And then also like, okay, so if we're at like the end of the array, and then because of its adding x, it becomes bigger than the array, then it just won't do the for loop because it'll be bigger than the size. Sorry, not the array, the list. So yeah, okay, so basically what I'm saying is, okay, say x is 2, and we got 1, 2, 3, 4, 5 is our list. It'll I will be 1, and then j will be um 1, 2. I guess yeah, it'll be j will be 3, and it'll start from there. Go 3, 4, 5, and then I will be 2, and we'll start at 4, and we'll do 4 and 5. So that's what that for loop is doing. Yeah, and then basically saying, hey, I minus j, and then find the absolute value of that. And that's what cur is. I was using cur a lot in the previous one, so it was like still on my mind. Um, so yeah, cur, and then yeah, if cur is smaller than min, then that's our new minimum. So yeah, I guess this takes too long. Is what that's what because it comes out with the right answer. It's the simplest way. Has very few lines of code. Um, I don't know what you would do to get it shorter, but I'm sure there's something. I don't know myself. If you know how a faster way, I don't know. Shoot me the code in the comments. I'm sure it'll fit. I can't imagine it be that long, but if yeah, so just or send me a video in the comments, a YouTube video. Um, yeah, I don't know. I don't want anybody sending viruses or something. So, don't if you don't feel comfortable clicking a link, I don't blame you. Don't click a link you don't trust. Um, yeah, so that I don't. I'm just trying to encourage people to try it. Maybe they can figure out a solution. I don't know myself though. So that was this week. Oh boy, this was a long one. I figured this video might be a bit long. But I wanted to make sure I explained everything. Um, so yeah, I was talking about how I was slowing down a bit. So I was hoping this week I show you I'm not slowing down. I gave it my best shot. I think I did pretty good. I got two questions done. I'm really proud of this one. This linked list. Um, had to pull from my classes to remember how to do that. But yeah, that was this week. I hope you guys enjoyed. If you're still watching, go to the comments, comment, I'm a cool cowboy. You comment that, I'll think you're a cool cowboy if you comment that. Um, yeah, so I hope you guys enjoyed the past week. I hope you guys have a good week, and I'll see you guys next time. Bye.